Good morning, students. This is Latif sir. On the first video on P block elements, I have discussed about group 15 and 16 elements, and in this video, I am going to discuss about group 17 and group 18 elements. First, see group 17 elements. The elements are fluorine, chlorine, bromine, iodine, and astatine. And first, you have to read some physical properties of group 17 elements like atomic and ionic radii, ionization energy. Okay, so atomic and ionic radii, halogen have the smallest atomic radii. Halogen, that is fluorine, chlorine, bromine, iodine. These elements have the smallest atomic radii in their respective periods because of maximum effective nuclear charge. And ionization enthalpy, halogens have very high ionization enthalpy because the size is very small compared to other groups. And electron gain enthalpy, halogen have the maximum electron gain enthalpy because this element have only one electron less than the stable noble gas electronic configuration. And electronegativity, these are highly electronegative element. All noble gases are highly electronegative element, and electronegativity decreases down the group. Bond dissociation energy, bond dissociation energy or bond dissociation enthalpy. The bond dissociation enthalpy follows the order Cl2 is greater than Br2 greater than F2 greater than I2. Now, oxidizing power of different halogen. All halogens are a strong oxidizing agent. All halogens are strong oxidizing agent because they have a strong tendency to accept electron, and the oxidizing power of different halogen is F2 greater than Cl2 greater than Br2 greater than I2. This is the oxidizing power order. Now, reactivity with hydrogen. All halogen reacts with hydrogen and forms hydrogen halide like HX, that means HF, HCl, HBr, HI. The acidic strength of different hydrogen halide is HF less than HCl less than HBr is less than HI. This is due to down the group, the bond length increases and bond dissociation energy decreases. Okay, so acidic nature increases. Stability order of different hydrogen halide is HF is greater than HCl is greater than HBr is greater than HI. HF greater than HCl greater than HBr greater than HI. This is because of decrease in bond dissociation enthalpy. Boiling point order. Boiling point order is HCl less than HBr less than HI less than HF. Boiling point order is HCl less than HBr less than HI less than HF. And HF is the strong, HF has the maximum boiling point. This is because HF has strong intermolecular hydrogen bonding. HF molecule can form strong intermolecular hydrogen bonding. And a percentage of ionic character dipole moment. This and reducing character you have to read. Reducing character. The reducing character order of different hydrogen halide is HF less than HCl less than HBr less than HI. This is the reducing power. HI is the the reducing power of HI is maximum. Okay. Now reaction with metals. Halogen react with metal and form halides. And ionic character of different metal halides is in the order MF is greater than MCl, where M is the metal. Okay, ionic character of different metal halide is in the order MF greater than MCl greater than MBr greater than MI. An interhalogen compound. This is important term. You have to remember what is interhalogen compound. This is a compound formed by reaction of two different halogen. Okay, Binary compounds of two different halogen atoms of the general formula x dash n, where x is one type of halogen another and x dash is another type of halogen. Okay, like ICl, IF. So binary compounds of different halogen atoms of general formula x dash n are called interhalogen compound. You have to remember interhalogen compound. This is important. Okay, where n is 1, 3, 5 and 7, and these all interhalogen compounds are covalent compound. Some example of interhalogen compounds like ICl3, uh, IF7. These are interhalogen compound. IF7, fluorine and iodine form interhalogen compound IF7. Here preparation of chlorine given here. You can see a compound of group 17 element of compound of group 17 element chlorine first. So laboratory preparation of chlorine. It is prepared by heating manganese dioxide with concentrated hydrochloric acid. When manganese dioxide is heated with concentrated hydrochloric acid, you will get chlorine gas. So the reaction is MnO2 plus 4HCl arrow MnCl2 plus Cl2 plus H2O. So by reaction of MnO2, reaction between MnO2 and HCl, you will get chlorine gas. So MnO2 plus 4HCl arrow MnCl2 plus Cl2 plus 2H2O. Similarly, you can prepare chlorine gas by reaction of NaCl, MnO2 and H2SO4 solution. When a mixture of common salt and concentrated sulfuric acid is used in place of HCl, you can also get chlorine gas. The reaction is NaCl plus MnO2 plus H2SO4. The product is MnCl2 plus NaHSO4 plus H2O plus chlorine. So by using this reaction also you can prepare chlorine gas. Now reaction of chlorine, reaction with alkali. In cold condition, chlorine reacts with strong alkali to form chloride and hypochlorite, and the reaction is NaOH plus Cl2. NaOH plus Cl2. The products are NaCl, sodium chloride, and NaClO, sodium hypochlorite plus water. So in cold condition, chlorine reacts with strong alkali to form chlorides and hypochlorite. But in hot condition, chlorine reacts with strong alkali like NaOH or KOH and produce chloride and chlorates, not in this case chloride and chlorates. But when the chlorine reacts with chlorine reacts in cold condition, then the products are sodium chloride and sodium hypochlorites. But when reacts in hot condition, when chlorine reacts with NaOH, the product will be sodium chloride and sodium chlorates, NaCl plus NaClO3 plus water plus 3H2. So the reaction is 6 NaOH plus 3 Cl2 arrow 5 NaCl plus NaClO3 plus 3H2. Now reaction with ammonia. If ammonia is excess, chlorine reacts with ammonia and form ammonium chloride and nitrogen gas. Ammonium chloride and nitrogen gas. But if chlorine is excess, then the product is chlorine trichloride NCl3 plus HCl. And here are some example of interhalogen given ClF, BrF, okay, uh, ClF5, BrF5, IF5, IF7. These are some example of interhalogen compound. And interhalogens, all interhalogens are more reactive than any halogen. Okay, interhalogen compounds are more reactive than halogen because the X dash bond is more polar bond than XX bond. And the last group 18 elements. that is inert gases, inert element or noble gases, fluorine, helium, neon, argon, krypton, and xenon, and radon. And their physical properties given ionization enthalpy and atomic radius. They have a high ionization enthalpy, okay, and electron and gain enthalpy. They have melting point, boiling point. These are some basic physical properties of group 18 elements, not given in the reduced syllabus. Okay, that's why I have not marked. And noble gases are generally unreactive, but some noble gases like xenon, krypton can form compound with fluorine, like XeF2, XeF6, XeF4. Okay, so compounds of xenon and fluorine, the compounds are XeF2, XeF4, XeF6. Okay, like this. When xenon reacts with fluorine, xenon fluoride will be formed. At different temperature, different types of xenon fluoride will be formed. Okay, when xenon reacts with fluorine at 673 Kelvin and at 1 bar pressure, the product is xenon fluoride XeF2. But when xenon reacts with fluorine at 873 Kelvin and in presence of 7 bar atomic pressure, atmospheric pressure, 7 bar pressure, the product is XeF4. Now, compounds of xenon and oxygen. Hydrolysis product of xenon fluoride. This is the last point. Hydrolysis product of xenon fluoride. When xenon fluoride XeF4 reacts with water, the product is xenon plus XeO3 plus HF plus O2. So the main net reaction is 6 XeF4 plus 12 H2, the arrow 4 Xe plus 2 XeO3 plus 24 HF plus 3 O2. And when XeF6 reacts with water, then the product will be XeO3 plus 6 HF. Okay, so you have to read the reaction between different xenon fluoride with water and with silica SiO2. It is given in your book, you can check, and just you have to follow the reduced syllabus. Okay, thank you, student.